Hi, welcome to Synthetic Division Part 3, where we are going to factorise using our eyes. We're going to do this over complex number, so what we have to do is we have to factorise x squared plus 9. So we know that 9 is made up of 3 times 3, and because it's complex numbers, I'm going to choose 3i times 3i. That makes negative 9. So start with 0, that's why I put 3i there. Multiply, add going up, and multiply to give negative 9. So 0 is what we want. We know it's a factor. And this gives me my remaining one, x plus 3i. And this one here was x minus 3i. Those are conjugate pairs, which we would expect when there are no I terms in the question there. So let's do x4 minus 81. So what we've got here, 3 times 3 times 3 times 3 is 81. But because it's over complex numbers, what we're going to do is we're going to use 3i. Now I've got 1x to the power of 4. I've got no x cubes, no x squared, so no x's. It's important to put those in. Start with a 0. This makes adding really easy. 3 times 3 is 9, so that's negative 9. Then 3 times that is negative 27i, so that stays the same. And 3 times 27 is 81, and the negatives will cancel out. So we get 0, which is what we want. Now we use the second bit on the top for our next one, because we have to factorize the whole thing. So I've got 1 minus 3i minus 9 minus 27i, and I'm going to do it by minus 3i, because these must come in conjugate pairs. That's negative 3i. When you add that together, that's handy. That makes 0. That's negative 9. So far easy. That's 27i. And it adds to make 0. That's good. So that stands for 1x squared. So then we've got x squared minus 9. We need to factorize that. That is going to be x plus 3 and x minus 3. And we've got our question there, which is x minus 3i for the first one we did, and x plus 3i for this one here. Here was the other bracket there. Okay, so that makes it easy. We'll go on to the next one. We have to show that both of these are factors. So I'm going to choose x minus I. I've written out the 3, minus I, 10, and 8i, negative 8i there. Put my I term. Remember, it's the root that we're doing, not the factor. We start with a 0. 3i, that makes 2i. That's negative 2, 8, negative 8i. Sorry, that's positive 8i, which is good because it gives us 0, which is what we want. Now we've got to show that x plus 2i is a factor, so I'm going to take the top here and I'm going to write 2i there, so I'm going to go 3, 2i, and 8. That's that top line there. And again, start with 0, add going up, so that's negative 6i, that's negative 4i, and that cancels out to negative 8. 0 is what we want, so we know that our other factor is 3x minus 4i. And we've answered the question. We have found the other factor, and we've shown that there's no remainders. Question done and dusted. Easy with synthetic division. So that's all for today.